Hello guys, welcome to the session. Let me share my screen. I hope it is visible to everyone. So very interesting thing, right? We are going to discuss today is the BGP MAD, right? I know you guys are aware about it. If you're not aware, I'll make sure you just have the basic to advanced understanding about the MAD. So we have the various protocol in routing domain. We have the IGP, we have the BGP. So in the BGP, we have the multiple attributes. So by considering those attributes, we have done discussion like a few attributes already in the past sessions where we discuss about that how the path selection process is going to be happen. How my next hope should be accessible. Then we have discussed about the what is my weight. We discuss about the local preference, right? But we tested for the local preference how the manipulation is happening in the previous sessions. Also, we discussed about the AS path. We'll do the again further discussion how the AS path prepend is going to be look like in the complex scenario. And also we have the origin type, right? So origin type, we have the IGP, EGP, and the incomplete. So we'll have the test labs on this also, how it is going to influence our path in terms of the inbound and outbound. But today, what we are going to discuss, that is a very important, the MAD. Okay. So what is the MAD? First, we have to understand what is the MAD and which scenario we should use the MAD. What does mean MAD basically? So we'll try to explore those all things. So you can see here, MAD is known as the multi-exit discrimination, right? So how this is going to happen, right? How this discriminator is going to be look like, multi-exit discriminator is going to look like. Let me put the here name, full name. So at least you guys understand. So if I talk about the MAD, that is known as the multi-exit, right? So basically, if you talk about this attribute is used to influence your inbound traffic, right? It is used to influence your inbound traffic, right? So if I'm saying inbound traffic, that means whenever you just apply this attribute, you always have to apply in the outbound direction. What does mean? Probably you not understand. So let me give one of the scenario examples so you can understand easily. Let's suppose I have this router and I have this router, okay? This and this router. And they have the BGP relationship. So this is the R1 and this is the R2 and this is the R3. So let's suppose you sending some prefixes from this router to this router or this router to this router. Let's suppose they are in the same AS. Just think about they are in the same AS. Behind we have the switch. Okay. We have the LAN here. We are going to do the same lab in the lab scenario 168.10.10. Just think about this is the LAN subnet. Sorry, let me make it the correct writing. So the LAN subnet is my 192.168.10.10/24. This is the R1. Might be we have the loopback address is 5.5.5.5.5/32. Just take an example. So how the MAD is going to play a vital role and how this is going to influence my inbound traffic, that concept we have to understand. It's a very important thing. People always confused about inbound and outbound direction manipulation. So when I talk about the MAD, MAD is known as the multi-exit discriminator. That is a BGP attribute that is used to influence your inbound traffic by indicating or sending the prefix your BGP neighbor AS. BGP neighbor AS means another AS. Might be this AS is 6455. So this is my another router connected with ISP, which have the AS number might be 6400. So when I'm sending the prefix either from this AS to this AS, I can use the MAD to influence my path. Or if I'm sending the prefix from this neighbor to this neighbor, this is also possible. I can influence my path, right? So that's why it's indicating the external neighbors, external peer. It's always going to use in case of the I have the eBGP peers, and my MAD is going to help to decide which route I need to take to go out. So what does means go out? So take an example. This router, think about this route. This is your office location. How inbound manipulation is happening. This router, I want, if anyone want to come from this particular AS number, this could be a data center, This could be another branch location. This could be your another ISP network. But you want, if somebody want to come in this particular LAN subnet, basically my traffic should come via this path. So means you forcing this router whenever he want to come from this particular, it will take this path to reach this particular prefix. This is your inbound traffic. Means you doing some kind of the segregation, you doing some kind of the manipulation. By doing that manipulation, if this always try to ping or trace or reach, it will always going to take this path. So traffic is going to in via this router. This is how your inbound manipulation is going to happen. So you forcing with the attribute, it always come via this path. That is the inbound. So MAD is going to configure here to just do that. But how MAD is going to configure? MAD, when this prefix is going to be sent out, when this prefix is going to advertise from this neighbor, this is the eBGP neighbor, this is also eBGP neighbor. So while advertising, it will set the MAD value. So when it is advertised from here, it will set MAD value, let's suppose 50. This is the MAD value. And this also going to advertise MAD value here is 100. So this MAD is going to advertise from this neighbor as well. So 50 is from here, 100 is from here. So now when this router is going to receive this prefix, it will receive 2 copies of the prefix. Means 2 network is going to receive here. One is you have the 50 MAD, another having the 100 MAD. So now which I am going to choose and install in my routing table? The MAD which having the lower value. So most important, you have to take a special note it here. The lower MAD value is going to take a preference over the higher MAD value. Means the route which is going to install in my routing table, which having the lower MAD value, means 51 is going to install. Means this router having the RIP table, this having the FIB table. So RIP table having a 2 copy of the route, but FIB table having the single route, which is the best route, which have the lower MAD. That's why it is going to take from this path. So it is going to configure outbound direction. Means when the prefix is going to advertise from this router, it is going to send to out of the neighbor by putting this 50 MAD value. When it is going to send this neighbor, it is going to put in out by putting the 100 of MAD. So you are applying outbound direction, your policy, you are applying outbound direction to the MAD value, but in return, you are getting the inbound route. That is the inbound manipulation. So whenever you just do the inbound manipulation, that means you're sending your attribute in out direction. Whenever you're going to do the outbound manipulation, that means you're sending attribute in inbound direction. That's the key concept you have to always understand. So local preference always going to apply in the, inbound direction. So it is going to enforce your outbound direction traffic. So local preference you use for the outbound manipulation. MAD you use for the inbound manipulation. So I hope you guys understand it. If any question, just put in the chat or comment. So let me clear this. So we'll test this lab. So that's why if I talk about the MAD again, so MAD basically is one of the attribute which is going to use to just manipulate our inbound traffic. This attribute is always going to prefer which have the lower value. Means if I have the lower value of the MAD, it is going to prefer, right? This attribute is known as the optional and non-transitive attribute. By default, it is not going to be like transmitted with the all packets. So it is a non-transitive. Whenever you want to transit, that is going to happen. By default, it's not a mandatory attribute. It is not going to by default, well-known mandatory attribute kind of a transmission is not going to happen. So only shared between directly connected neighbors and not going to propagate for the neighbor. One more thing you just have to understand, option non-transitive attribute is this. Apart from that, whenever you just configure the MAD, most important, as we know that if I am going to configure the weight is local to the router, weight attribute, it is always going to local to the router. Local to the router means within the router, weight is going to work. Weight attribute means if I have 2 link and I want to compare, this is going to work. Okay. If I going to configure the local preference, right? Local preference. See, it is going to stay within the AS means this local preference significance is it is just going to carry within the AS. Means if I want to compare 2 local preference within the same AS, it is possible. But if I talk about the MAD can travel from one AS to another AS. MAD can travel from one MAD. If you just set the MAD value here, it will travel to this. If you said it will travel to this, it will travel to this, it will travel to within the AS, it is going to travel till here. But this MAD, if the same route you want to transmit to this neighbor, this neighbor, this neighbor, this neighbor, the MAD value, whatever you set it, let's suppose you set it 50 here, 100 here. It will still carry here 50, 100, it will carry the route. But when you send the route another eBGP neighbor into another third AS number, this is going to wipe out. Most important thing, you just have to take a note. Means MAD, if you're just going to configure, it is going to be set it there. After that, it is going to be wipe out. It is not going to be available. So that's why very important concept here. You have to take a note. MAD does not propagate beyond the AS, means neighbor AS. Whatever the neighbor AS receive that, it is not going to propagate further any AS. Means if AS A is sending the route to AS B, ASB further not send the attribute to ASC or ASD, whatever it is. That's the most important thing you have to understand. Lower MAD is always going to be preferred. Higher is not going to be preferred. If we have the equal MADs, then my other attribute is going to take a precedent further to the tiebreaker. So let's suppose I am receiving the same attribute right now, both MAD is same. And I have the same kind of this attribute also. Let's suppose I'm just thinking about my locally originated route is next hop is accessible, locally originated route is same, right? Weight is same. I have the same AS path repent. I have the same type of origin. I have the same type of the, MAD, means the MAD value is, let's suppose 100 both sides. Then what is next? So then the next tiebreaker is this 8, means all preceding scenario are identical, means till 1 to 7 are identical. Further route can be reached via the closest IGP neighbor. We'll discuss what does mean, right? That going to take a sorted path. If everything is going to send, then lower router ID or might be the lower neighbor IP is going to break the tiebreaker. So this is how the path selection is going to happen. So if same MAD, then we just have to move further. And then if all are going to identical, then you just have to do the tiebreaker based on the lowest IP address, whatever we have. Okay. So I hope you guys understand it. Now, let me just do the testing, how this MAD is going to configure and how step by step we can do the verification. This is a scenario you can see here. So right now, what is happening? This is one AS number, and this AS number, I have the one of the LAN prefix. You can see this is my LAN, which is configured by this PC. This LAN is getting advertised from this CE to this CE from this PE. Means this is another DC network I have. So this is getting the same route, this is getting the same route, and this is my server where every route is available. So we'll do and check how the current behavior right now with the MAD. Right now, I configure the local preference based on the previous lecture. And right now, one path is getting preferred due to the local preference configuration. So what I'll do that, LP configuration, I'll remove that and I will see the default attribute behavior, what is happening. So if my LP is not there, then it will keep checking the other attribute. Means LP is here, you can see. So it will go 4, 5, 6, 7, and last it is going to do the tie break based on the 9th, right? So let me see what is happening right now. So if I go here in R4, P router, and you can see we are targeting this one, which is getting advertised from this particular AS number, which is my office location. So let me go in the P router and see what is happening right now. So if I go in the P router and if I check show IP BGP, you see I have getting this route. See here, this route I'm getting 192.160. The best route I'm getting from the higher LP, which is the 89.0.02, because I have the 150 LP and 79 neighbor have the 100 LP. So based on that, the LP is doing the path manipulation because we configured the LP. So one is this neighbor, one is this neighbor. This neighbor is getting preferred because have the higher LP if I compare with this neighbor. So if you want to check in more about the what MAD value is coming, so you can run the command show IP BGP and you just put the command here 192.168.10.10 0/24. You put this command, you'll see other attribute value. So you can see I'm targeting one prefix. So in this prefix, you can see I have two neighbors. One is this, one is this. But you can see the best one. Which one is the best? Why it is best? Because I have the local preference attribute set here 150, local preference attribute set 100. So higher local preference always going to be take a precedent over the lower. You can see the metric. Metric is your MAD value. This MAD is both metric is 2, means both are getting same metric, means MAD is equal. But MAD is not going to come in consideration because path selection, BGP path selection, how it is going to, first they are going to check next hop reachability. That is fine. Second, they are going to check weight, right? That is also not available here. This also, okay, this is not consideration. Then the local preference, third one. Fourth one, locally originated AS path, right? Then we have the MED. So MED is going to later stage, but before MED, we have the LP, which is taking the precedent and is showing that this is going to become a best path because I have the higher LP. So let me remove this LP and we'll see how the further selection is going to happen. Then we'll tweak with the help of the MED. Okay. So let me go and remove this LP configuration first. So what I can do that, I will go on this particular P router and this P router have the LP configuration. Let me see that. And let me remove this LP. So show run section BGP. This is my, so this is not, this router no LP configuration because default is 100. So no LP is configured. So let me go in the P4 now. And I'll see what is the on the P4 section BGP. And here you can see, okay, so here we have the local preference. So let me check show route map. And let me check what configure. I believe 150 configure here only. That's why it's propagating. Yeah. So we have the one prefix and we have the LAN subnet. You can see if you check the prefix list for what LAN. So probably you're going to find the 192.168 subnet. Yeah, that's fine. So let me remove this particular neighbor LP configuration and I will see what is going to happen. So I'll go in the config T. I'll go in the router BGP 6455. And I'll remove this particular local preference configuration and we'll see what is the behavior of this particular route, which is coming in the P router. So you can see now LP has been removed. Okay. So now LP has been removed. Now let me go to the P router. So we are receiving 2 copy of route from here, from here. This route we are receiving 192.168 from here, from here. Earlier when it was landing, we are setting the LP value 150. Here was the default LP is the 100. So when it is propagating to this P router, he was sending with one LP 150, one is the 100. So higher is getting preferred. So right now there is no LP. Both are sending 100. Default LP is the 100. Let me show you. So I will go here. Okay, just give me 1 minute. So I will go on this router and let me run this command. You see here. Now you can see the magic. Now earlier LP was 150 and which was the best next of 189. Sorry, 89. But after removing the LP, you can see this is the 100 LP. This is the 100 LP. Metric is also same. So they are basically not doing any manipulation based on the LP. So, but my best route earlier was 89 neighbor, but now this is 79 neighbor. Why? Because the attribute, whatever I have, 1, 2, 3, 4, 5, 6, 7, 8, 9, all are identical. Means next hop is identical, weight is identical, LP is identical, origin identical, MED is identical, right? IGP, BGP, everything identical. So what is the tiebreaker? So lowest router ID or lowest configure interface IP address is a tiebreaker. That's why you see 79 is lower than 89. And based on that, they selected the best path as a 79 IP address, neighbor IP address. That's why they installed this route as a best route. So earlier it was going by the 89 because I have the higher local preference, but now it is start going by the 79 because I have the lower IP address, which is configured on my WAN interface. Okay. So now what I have to do that, currently 79 is my best route. So let make 89 as the best route by doing the MED setting. Means what I can do that, you can see MED value is 2 here and 2 here, both having the same MED value. So what I can do that, I can make MED 100 here, I can make MED 50 here. So if I make the MED 100 here, this MED is the higher, this MED is the lower. So if I do the MED setting 50, so 50 is always going to take precedent over the 100. So how the attribute selection is going to happen? Let me just go here. So first it will check the next hop, that is the same, means everything is fine, there's no problem. They're going to check the weight, that is not in picture because weight is not going to be configured here. LP is not in consideration, both are the same LP. Locally originated route, like you can see, there is no locally originated route, local preference in the same. So we have the local preference, no AS path, we are all the AS path is same, AS path also same. So now it's come to the MED. So MAD, we configuring one neighbor as 100, one neighbor as a 50. So 50 is going to take a precedent because lower is going to be choose on the higher one. So let me do that. So how it is going to be configured? So basically what I have to do that, I have to go on the not P router, I have to go in the C router because this C router needs to advertise the route with the MAD value. So this will get influenced here. So I have to go in the C router and I will do some kind of a sort of the configuration for this particular prefix. I can apply for the all prefix. I can apply for the any single prefix as well. So let me do that, how it is going to happen. So I'll go in the C router, you can see here. And because I want to influence to the MAD here, so I will do the changes in my AS, then it is going to send in out direction. So he will try to come in inbound, then it is getting the best path. So if I go here, so IP route 192.168.10.0, you see this is my route, it is coming. And this is another router. So enable show IP route. And this is also getting. So let me do one thing. I will set up lower here. I'll set the 50 MAD here from this neighbor. Means I'll go here 50 MAD here and 100 here. Okay. So this is the 100 MAD. This is the 50 MAD. So this will receive the MAD 50 here, 100 here, and it will send to both here. So once it will receive 100 here from this one, 50 here, so it will choose the 50 and it will go via the 89. Right now it is going via the 79. So let me do that, how it is going to happen. So I will go here and simply go in the configuration. And let me just check the to show run section BGP. So I have the BGP configuration. So I'll create one of the prefix list, that's a LAN prefix list, right? And based on that, I can apply that. So I can create IP prefix list, LAN subnet, okay, and commit 10 and sorry, 192.168.10.0/24 commit. Just give me 1 minute. LAN subnet, right? Commit 10, commit. Yes, I have to put the IP address. I was thinking why it is not coming, right? 0. So that is done. So I just created one of the prefix list. I just commit one subnet. Okay. Now what I have to do that, I have to get a route map. So I hope you guys are aware of the route map. And I'll put the route MAD set MAD. So this is my route map name, set MAD, commit 10. And what I'll do that, set IP match IP prefix list, IP address, prefix list, and I will match the subnet for the LAN one. So I'm just going to match under the router one prefix, that is a 192.168.10.0. And then after I'll set metric here. Set metric, how much metric I want to set? Metric is the MAD. So I'm on the C2, so I just want to make metric 50 here. So I will set metric 50 here. It is done. So let me show you what I have done that. Show run section route map if I do that. And you see here route map. This is my route map. I just match one of the IP address. IP address is subnet. And then I set the metric. So this is what I have done. Now, under this LAN subnet, if you check the prefix list, so I just configure the prefix list. That is my subnet. This is my subnet. What next? So I have just go in the section BGP. On section BGP, if you go here, you have this BGP configuration. So now I have to apply against this neighbor in my outbound direction. This is the most important. If I'm going to apply in outbound direction, that is going to influence my inbound direction. So I will apply in the outbound direction. How it is going to happen? So I will go in the configuration here and route map. Sorry, not route map. Router BGP And what is my BGP? 64002. And neighbor, what is my neighbor? Let me check it. So 210. So I will go here and I'll put the route map. Sorry, 2-time neighbor I copied. So that's by creating a problem. So let me remove it. So route map. And this route map name is, where is my route map name? Set MED. Okay. So you just have to copy, and now it is asking which direction you want to apply. So this is the most direction is the most important. So we are sending this MED value to my neighbor, like AS number, so he can come to me as per my preference. So I will send in the out direction. So that's done. Okay, so that's done. So show run section BGP, you can see it here. So run section BGP, we apply it here. So one side configuration I have done, that is a 50 MED. Now I have to do the same configuration on another subnet. So let me just do things here. So run section prefix list. So I copy the prefix list. I'll copy the route map. I'll just paste to another router. Or I can do in this way. I can simply go in the C router. I can create the same thing. So I can create the IP prefix list, right? LAN subnet, right? And permit. And after I'll put the 192.168.10.0/24. And I create the route map. I'll create the set MED. Okay, permit 10 match IP address prefix list. Okay, this prefix list is this one LAN subnet. So I'll just match it, and then I'll set metric. And what is my metric? This time I'll metric use 100 because I want to make 100 metric here, 50 metric toward this neighbor. So it is less preferred from this router perspective. Okay, and then what I'll do that show run section BGP. So after going and save run section BGP, you see here. So now I will go on this particular neighbor, 100 neighbor, and I'll apply this particular in my outbound direction for my particular MED. So I will go here. And then I'll just check the neighbor. This is my neighbor. And I'll put the route map. And what is my route map? This time I have this route map, and I'll put the outbound direction. This is done. You can see here. So LP will also apply, and now I apply my MED value as well. So this is done. So let me write the configuration. Let me write the configuration here as well. So both configuration I have done the right. After that, I will go on this particular P router. Let's go first P router. What is happening when this prefix is receiving? So if I go in the P router and you just run the command, show IP BGP 192.168.10.10. You see this metric is coming with 100. Okay. Local message is also coming with 100 for the PE2. So we are PE2 100 because we set the 100, but let's go on the PE4. So PE4, let me see, should be 50. Let me check it. Show IP BGP 192.168.10.10. Yes, it is coming with the 50 and local pin is 100. So now it is very much clear. We setted the particular attribute that is a 50, that is 100 in out direction, and it is coming. Then it will send to this P router because within the AS it is going to there. So earlier there was a 2 and 2 both sides, but now I have to change the value, means already changed the value. So let me see the result. What is happening now on the P point of view? So let me go on the P. This was my old output, you can see, where my metric was 2 and 2 from the both neighbor. And this was the best. I want to make this one as a best. Okay. So let me check what is happening here. So I will just go here and I'll just run show IP BGP. And I'll put the 192.168.10.10. Can you see here? So now you can see automatic my 89 network become the best, which have the metric 50. And this has become the non-best because have the metric 100. So this is how my path has been manipulated. Means if I originate the traffic, earlier it was going by the 79. So now because I have the lower metric, so it will always follow this path to reach the destination. Earlier it was going by this. So this is how you can manipulate the path based on the MED value. So in addition of that, we have also some key concept with the MED, like we just have to understand what is my always compare MED, what is my deterministic MED, right? So those also I will explain in the next class, right? How it is going to be happen. Just give me 1 minute. So, but for time being, at least you understand why MED attribute is very important, how MED is going to configure to influence my path. Most important, whenever you're going to configure the MED, it is always going to send out, okay? But it is going to influence your inbound path. That's why it's the inbound path manipulation attribute. Another important thing you just have to remember, whenever you set the any attribute MED, it will just stay till your neighbor AS. It will further not going to propagate any other AS. Means MED value, if you send it from one neighbor to another neighbor, it is going to stay there, but it is not going to further share with another. If you share this route to this particular AS, MED is going to be removed, wipe out. That's the key concept. So next thing I have to explain how the MED is going to compare between the AS, right? Means if I have the attributes are coming from different AS, then how MED is going to be configured, right? So we have the concept is the always compare MED, means MED always how it is going to be compared. Deterministic MED, how within the same AS I have getting the multiple AS, then how it is going to be like compare. So basically, if I talk about the always compare MED, that let me theoretically just explain. Later we'll do the practical things. So we have the one concept is the always compare MED. Another concept we have that is the deterministic MED. So sorry. So first let's discuss the always compare MED, and then we have to discuss about the deterministic MED. Let me write it here first, so at least you understand. Probably people are always like confused about that. So one is the concept is the deterministic MED. So what does means always compare MED and what does means the deterministic MED? So simple thing, right? If I talk about the always compare MED, so it means this option basically allow you, if you are getting the multiple MEDs from the different MED, means you are going to get the same prefix from the different autonomous system, right? So by default, if you want to compare the MED between those routes which are coming from the different autonomous system, so it is not available. Means you can think in this way. You can think in this way. This is my 1P, getting one route from this AS, getting route from this AS, getting route from this AS. 3 routes are coming. By default, they are not going to compare the MED value. Means same 192 route I'm getting from here, same 192 getting from here, same getting from here. By default, they are not going to compare the MED value unless you enable this always compare MED command. This feature you have to enable in the global configuration. I'll show in the lab. There is a command known as the BGP always compare MED. This command you have to run in the BGP configuration. Let me show you how it is going to look like. So once you run this command, let me just go in the configuration. Router BGP 6455. You just have to run the command BGP always compare. This command is going to give the flexibility to just compare the MED between the multiple AS which are going to belong in the different AS system. Clear? So this is how it is going to be tested. I'll show you. Now talk about the deterministic MED. So basically what is going to happen in deterministic MED is something, if you want to compare the multiple route subnet which is coming in the same subnet, means this option ensure that MED is going to compare in when multiple route is coming with the same AS through the different BGP neighbor, might be the IBGP, eBGP, but within the same AS, they are coming with a different neighbor and you want to compare that. Then it is going to compare the deterministic MED. I'll explain how it is going to look like exactly with the lab, because if I explain right now, theoretically, probably you're not going to understand. But I'll do that. I'll take another lecture where I'll just do this MED. MED we understand today. Now we'll make one scenario where I'll always compare MED with the different OS, means AS number which is going to be connected, and same time how within the same AS number, when multiple routes are coming from different BGP source neighbors, then deterministic MED is how it is going to be look like to compare them to just which best path is going to be come and install in the routing table. So you just have to do one thing. If you want to enable the deterministic MEDs, just you have to write the command here, BGP deterministic MED. It is a very good question in the interview. What is a deterministic MED and what is always compare MED? So just giving the simple definition. If you have something compare, all AS means different AS, then your always compare MED is going to come in a picture. If you want to compare within the AS of the different metric, then your deterministic MED is going to come in a picture. Clear? So this is how it is going to be look like. So thanks for today's session, right? Next section, that is going to be 100% lab-based deterministic MED test and the always compare MED. So you can clearly explain the interview. All right, guys. Bye-bye.